Assalamualaikum warahmatullahi wabarakatuh and good day again. Hi everyone. So this is soil mechanics and we are in last chapter, the shear strength. Okay, shear strength of soil. Okay, note that different material have a different definition of their strength. And for soils, we define our strength in the shear manner. If you have an idea what is shear compared to compression strength, compared to tensile or normal strength, so you can also Google for the definition of shear itself. But in general, we can representing a shear such as two different soil condition. Let's say this is a slope in the soil. So when a stable condition, soil is acting as a one whole body, or we call that as a mass body of mass. However, when they have starting showing a failure in the strength, so somehow a failure strength, a failure envelope or failure line is occurred. Failure envelope occurred, and the whole mass body that split from the bottom side will tend to fail and move. So that's why in the soil we usually sees the failure of soil in terms of slope failure due to the land that slides from the original from the failure envelope lah, from the failure envelope. So what the bottom part of the soil or ground try to do is actually try to resist. So resisting and disturbing of the whole equilibrium soil condition is defined in the shear strength manner. Next, in next slide, you will see the differences between strength parameter that we can see in different type of material. Now we have a steel. Okay, so steel have their strength in the tensile. So once there any work that need for strength in order that we have a load pull the materials, so it is a tensile strength. And for concrete, they have a very good compression strength. So once we have either compression from top to bottom or either from left to right, so concrete have a very good compressive strength. But bear in mind, concrete also not very good when it comes to a tensile strength. So that's why when we design a beam, okay, when we design a beam to support a building, so that's usually we design the beam comes with the concrete together with the steel, or we call them as a reinforced concrete. So usually we will implant a steel to strengthen the beam inside, and then we pour the concrete. We let the beam to become strength at the desired strength that we want. We can have a C50, usually used for tunnel lining, and usually for building we can have C30 and lesser. But compared to these two kinds of materials, for soil we define the strength in the shear. So Sometimes in soil we have a one homogeneous soil, but here we can see there is two distinctive types of soil. So this kind of soil condition easily fail in the shear. And as we already learned in the previous chapter, okay, if you still recall, kind of, yeah. Okay. Um, so let's say we have a three-phase diagram. I hope we still recall we have a three-phase diagram of air, water, and also solid. So we know that we also learn from previous chapter of water in soil that when we have a soil layer, so we will induce normal stress, okay, total normal stress, pore water pressure U from gamma W and height, and also it will reduce the effective stress of the soil. Okay? So that's why the shear strength, when we go throughout this chapter, we will see that the percent of pore water pressure will highly affect the shear strength. Thus, the shear strength or the strength of the soil is a complex behavior, not direct approach such as concrete and also steel. Yeah. As we also know, soil is a good, not a man-made material, so it is given to us by God. So that's why we need to understand more on the shear strength and the factor that affect the strength of the soil. Okay, before we go further, so let's see a few questions that we need to have an idea before we go throughout the chapter. Okay, of course, what is the shear definition? What the factor will affect them? So later you will see that we will use Moore Coulomb failure criterion. So what is the Moore Coulomb? And note that during your learning, please differentiate what is drain, undrained shear strength, because it will be affected more in the design later on. And we also will see, I think, laboratory field tests. Okay, and those laboratory and tests is very important to define parameters. Okay, parameters, because more Coulomb have their own strength parameters. And last but not least, I hope throughout this chapter you will understand the big thing is the importance of knowing the or understanding the shear strength. Okay, knowing importance of knowing the shear strength. So shear strength tau at failure. Alright, so let's see this one uh, uh, sketching or schematic diagram on the strip footing. So note that a foundation will have a different type of foundation. So this one is shallow foundation. So sometimes in building we might also have a pile. So the piles is a deep foundation. So the piles or the strip footing or different type of foundation is usually there to bear the loading from the building. So when they bearing the building from the building, the ground that support the foundation is actually affected. So the original equilibrium of the ground is changed, and they might induce a shear stress. So this is disturbance, okay? Disturbance of shear stress due to the loading or due to the building on top of the ground. And at one time, after some limit, the failure line, the dotted line of red, is the failure line or failure envelope is might occur due to the excessive loading. So we can see the scenario at the failure line is actually disturbance shear stress. Try to put more strength to the soil, and at the bottom side of the failure line, the resisting force try to overcome the loading. So shear resistance and shear stress will produce stability if they still low, the disturbance factor or mobilized factor. If it is still low compared to the resisting force, shear resistant until failure, so it is safe. Okay, it is safe. But once the tau mobilized or disturbance is much more bigger than the tau that resisting until failure, so it is not safe anymore. At the failure line, the shear stress along the failure surface is called tau, and once it reach ultimate value, it is equal to the shear at failure or the shear strength. Shear at failure or shear strength. Alright. The shear strength application is very important, as I mentioned just now, for the bearing capacity of the soil. So once we know the tau failure, the limit of the shear strength, we can calculate how much the Q and what the design of the footing, either this one or with a pile, only a simple footing, or with a pile. So we can design properly for any high-rise building or any typical building. Next, it is very important in the slope. Okay, of course, because once the failure envelope generate, so slope might lose their stability. And it is also important when we have a retaining wall. So let's say we want to have a house near the high hill, okay, so house or any flat. So retaining wall is there to support. Okay, it will give a pressure, lateral pressure, but the inducement of the load of the weight and the lateral pressure itself, active pressure especially, will either overcome or make the retaining wall structure fails. So at the end, it might collapse, endanger lives, and causing economy damage. So this is an example of the catastrophic event due to the lack understanding of maybe the shear strength. It is a landslide, a slope failure on the Tanjung Buga. So this is another picture of, I think this is a combination of earthquake and also shear strength failure. And you can also see a lot of discussion out there, especially on the landslide, due to the shear strength concepts. Okay. Alright, in the slides, I'll provide a lot more slides definition on the shear failure. So you can see the soil generally fails in the shear. So we will induce the failure surface. So I think I stop here for now. So later we will continue in the next session for the more Coulomb equation.